All right, you just had a chance to sketch graph of this one, and I'm hoping that it went well. But this is how I would go about doing it. My first question is, I know that I can't divide by 0. So when would that happen? Look at this denominator, and I'm going to say, when would that denominator equal 0? Subtract 4 from both sides. X is negative 4. So x cannot be equal to negative 4. So that tells me where one of my asymptotes is, one of my vertical asymptotes. Let me sketch it. 1, 2, 3, 4. That's here. I didn't like where that ended up, so I'm going to redraw it. There we go. And then my next questions are, what happens as x gets really big positively? What happens as x gets really big negatively? And remember, what I'm doing there, one way to think about that is to think about the those leading terms, 3x over x. As x gets really large, positively or negatively, the -1 and the +4 don't matter. They get dwarfed by these terms. So essentially, when x gets really big, this becomes 3x over x. X's cancel, y is 3. So as x gets really large, this tends towards a y value of 3. It'll flatten out here and here. So I have those parts. So now what I'm going to do is try and get a sketch going on here. 3, 4. So let me plug in x is negative 1, 2, 3, 4, 5. Plug in negative 5 and see what happens. 3. Sorry about the ugly 3. 3 times negative 5 minus 1 over negative 5 plus 4. 3 times negative 5 is negative 15 minus 1 over negative 5 plus 4 is negative 1. Negative 16 over negative 1 is positive 16. So it's going to be way up here. So that means the shape is going to, it'll tend towards this line, and it'll tend towards that line up there. So it's going to do that over here. So I know that this is going to fall in over here. I just need to figure out where. So let me plug in an x value and get a y value for it. I'll do 1, 2, 3. X is negative 3. If I plug that in, I have 3 times negative 3 minus 1 over negative 3 plus 4. 3 times negative 3, it's negative 9. Negative 9 plus, minus 1 over negative 3 plus 4 is 1, negative 10. So when this is negative 3, this is negative 10. 1, 2, 3, 4. So it's going to be somewhere down here. So I know then that this shape is going to be somewhere in here. Notice I didn't work too hard to find these intercepts. It's all right. I don't mind. I could find this one pretty easily. X is 0. This is negative 1/4. So it's probably like more through here. But I'm really not going to make a huge deal out of that. But it is nice to get a reasonably accurate sketch, and that wasn't one. Something more like that. And again, you can always check this on your graphing calculator. We had this 3x minus 1 over x plus 4. I'll use Wolfram Alpha. Y equals, make sure you put the entire denominator in the in parentheses, and then divide, and then put the entire denominator in parentheses as well. Otherwise, you're going to get the wrong graph. Let's see what comes up. Yeah, that looks pretty close to what I have noticed. Negative 4, that's a good place for that. And then up here at about 3. Nice. Perfect. Okay. So let's do another example. And this example is going to up it a little bit too. It's going to look a little bit different than what we've done so far, but not that different. It's always the same questions. It's always the, am I dividing by 0? What happens as x gets big? So I don't like that color. I mean, I don't have anything against that color. I just want to use this color. Y is x plus 1 over 2x squared plus 5x minus 3. So, first question. Divide by 0. So I know that I'm not allowed to divide by 0. So the thing that I need to do is make sure that I'm not dividing by 0. So I'm going to take, just like I've been doing before, take this denominator, set it equal to 0. 2x squared plus 5x minus 3 equals 0. Okay, I have a quadratic equal to 0. I could run it through quadratic formula, run it in my calculator. I could complete the square. I could factor it, whatever. I think I'll factor it. I think, let's see, x plus 3, 2x minus 1. That gives me a 6x minus 1 is 5. Yeah, is 0. So it looks like x is negative 3 and positive 1/2. And notice I said x equals that because that's the solution to this. But x can't be those things because if I plug in either one, it makes that denominator 0. Can't divide by 0. Okay, so this one's kind of new because now I have 2 points, 2 places where I can't divide by 0. So x cannot be negative 3. So that gives me 1 asymptote here. And x also cannot be positive 1/2. That's going to give me an asymptote here as well. Okay, so that's kind of crazy, but it's all right. That's good information. My next question is what happens as x gets big positively? What happens as x gets big negatively? And I'm going to go with that same argument that I made earlier today, that the leading term is the important one. Like when x is really big in the top, in the numerator, this is the term that takes over. When x is 1,000,000, it dwarfs this. But then in the bottom, in the denominator, this 2x squared is the important one, because when x is like 1,000,000, you have 1,000,000 squared times 2, that starts to dwarf this 5 times 1,000,000. And if that doesn't convince you, make it bigger, 1,000,000,000 or whatever. So as x gets really big, this becomes x over 2x squared. You can do some division. 1x cancels one of those x's. 1 over 2x. So essentially, as x gets really big, this tends towards 1 over 2x, which is like those earlier problems we were doing. Like let x get really big, like x is 1,000,000, 1 over 2,000,000. Or 1,000,000,000, 1 over 2,000,000,000. What happens is as this denominator gets really big, this thing tends towards 0. So that gives us a asymptote at y equals 0. So now what I've done is I've kind of mapped out, like kind of given a little frame to the shape of this. And a couple things could happen. I could have something here or something here. In here, I'm probably going to end up with like some sort of parabola maybe. Or I might end up with something that looks like a cubic in here. Not sure. But then out here, I'm going to have something like this, something like this. So now's a good time. You could plug in points and start to sketch what you get. But now's a good time to step to that graphing calculator, and see what type of shape you get. So let's see. It was y is, make sure you use those parentheses, x plus 1 divided by, parentheses around the entire denominator, 2x squared plus 5x minus 3. Let's graph it. See what we got. Okay, so your graphing calculator is going to have a better scale than all this. Like in here, this is kind of a mess. It's hard to see, but there's a little bit of blue in here doing some stuff. But you can see it in here, that it goes from top down to bottom, that sort of thing. So let me go back to my graph. And so it looks like on the left-hand side, it's like this. Right-hand side, it's like that. So I know that I'm not going to worry where the actual points are. I just am worried about the frame, that sort of thing. And then on your graphing calculator, you'll see that, oops, I don't like that. Has a little shape that looks like that in there. And that's good enough. You know, what I'm going to look for on the test is where are your asymptotes, and do you have like general trend of what's happening with the graphs. All right, so here you go. I want you now to give this a try. Try this one. It's a lot like the one we just did. Sketch a graph of it, talk to each other about it, help each other out, discuss it as a class, come back and look at my solution. And then after this, we have one more idea I'm going to tack onto this, and then we'll be done.